Hi guys, welcome to watch again our video course on Ruff IoT application development. Well, in chapter 3, we mainly learned the networking operation in Ruff application development. That chapter mainly covers 3 communication protocols, namely TCP, HTTP, and MQTT. Then, in actual use, when we choose the TCP protocol or the HTTP protocol as our communication protocol. We're unavoidably facing such a restriction, the 2 protocols' communication parties must be in the same LAN to realize their mutual communication, which presents a problem. In the internet, we cannot access a development board under another network. The solution is quite simple though. We need to introduce a server, and this server must have an IP of the internet. With that, either a development board under a different network or a PC may access the server with an internet IP. As to the steps, look at this diagram. At first, the Ruff Development Board must initiate an access to this server, and the server must hold this connection. Then, the PC must access the server. Upon successful access, it sends a command to the server. And after getting this command, the server directly forwards it to the Ruff Development Board, which realizes such an effect. Since the server and development board have had a connection, when it receives info from the PC, the sent command may directly forward this command to the Ruff Development Board through this connection. In doing so, it realizes the previously mentioned effect of accessing a development board through the internet. Those attentive audiences may have noticed that it is actually, as mentioned before, a communication mode of MQTT. If, on a server, I initiate an MQTT broker, it can realize such an effect. Next, let's expand this node. It forms our current IoT application structure, and this application structure means end, cloud, end. The first end means the front end displaying the operation. Its necessary feature is provide a control GUI to control the final device. The cloud means the IoT Cloud. Its necessary features include data transfer, data storage analysis, process, and so on. And the second end actually means the terminal end, such as an acquisition-controlled terminal. Its necessary features include acquiring data from the sensor and the ability to control the final actuator, like LED, or motor, or relay. With these, a modern IoT application structure is formed. How about the advantages it has brought? There are mainly 2. One is the realization of feature, as we said before, of cross-network access. The other is that it divides the original development work of IoT application structure into some levels. After the division, there are 3 main development roles. One is the cloud provider, the second is the front-end developer, and the third one is the IoT device developer. A front-end developer, as I mentioned here, does not only refer to such a front-end developer of a web page, but a more generalized front-end. This front-end only needs to conduct data display and provide an operating interface. It may be one of our smartphones, or smart tablets, or a GUI tool on PC. All qualify. Once the 3 development decisions are made, our different development decisions may be developed within our own scope of development. It realizes such a division as well. What deserves attention here is the cloud server's developer. What it does is the IoT Cloud. It provides the front-end developer and the IoT device developer with SDKs respectively. It provides the front-end developer with a service SDK, and the front-end developer may rely on this SDK to acquire the data on the cloud and send a command to the cloud. And then, the cloud forwards this command to the final terminal device. Besides, the IoT Cloud also needs to provide the internet device developer with a device SDK. After the terminal developer gets this device SDK, he may submit the sensor data to the cloud through his or her own device, and receives at the cloud the data sent from the front end. Here some audiences may have such a puzzle. Isn't the MQTT, which we talked about before, with such a structure? Why do cloud service developers still make great effects on the IoT Cloud based on that? Actually, compared with MQTT, this mode has the following main features. One is that the cloud service developer realizes a server at this IoT Cloud of its own. It has a significant improvement in performance compared with some open MQTT servers. Its second feature is that it can expand the functions. An MQTT server, as we used before, may not have such functions as data processing, buffering, or storage, and so on. And in fact, an IoT operator may include them all. The third feature is that it simplifies operations, like some identity authentications or connection modes. These operations may be simplified through SDK. Alright, so that's all for this lesson. So please look forward to our upcoming classes on Ruff. Thank you very much.
Ruff, make IoT easier.